Okay, yeah. Hi everyone. In this session, we are going to discuss about uh, the use cases, how media processing systems are working, which is like media files are like JPG images or video files. How we can get the details from those type of media files data. So like the entire system, we are going to build it with the serverless architecture and AWS services, which is like AWS Recognition and S3, DynamoDB, SNS, and Lambda. So mainly AWS Recognition is playing a pivotal role in these use cases. So AWS Recognition is a service. It's a kind of computer vision platform. Through that, we can detect the objects, labels, and then we can create the custom objects. So let's go and check the recognition services. So it has various features. So such as like objects and scene detections, and then facial analysis, and then face comparison and search also we can do that, and celebrity recognition and text detection, and find out unsafe content details, and we can create the custom labels also we can create that, and then video analysis also we can do it with the AWS recognition. So that the service. We are going to use it in our media processing system use cases. So yeah, label detections, image properties, image moderation, face analysis, face and comparison, liveliness, celebrity recognition, text in the image, so PPE detection. So there are various use cases they are providing it. So now we are going to get the labels like the objects details and those like a meta details, the labels details we are going to get, receive it from uh, the images and the video files. Okay, that is the use cases we are going to implement today. So it will do image processing and video processing, like a video label detections, and it will go and analyze the video, and it will try to get the data about what is the objects in this video, and then it will return the data, and then all the details, labels, metadata, everything be stored in the DynamoDB table, and then we have a SNS notification as well. So once the process is done, then it will send the email to the specific user. And then the entire flow we are using serverless architecture we are following. So let's check the architecture diagram. Yeah. So first the user, they will upload certain files like image files or video files to S3 bucket. And then we have a S3 events notifications when there is a file uploaded to S3 bucket, and then it will trigger the event that will trigger the Lambda function, which is media processing Lambda functions. So that Lambda function, it actually connected with the AWS recognition, and then like a DynamoDB table and SNS notifications. So based on the media, the file type, whether it's an image, and then it will do certain kind level of process, and then it will get the data, and then it will store the data into the DynamoDB table along with the help of recognition service. And then finally, it will send the SNS notification. The same process for the video files. So these are the architectures. So architecture flow. Now let's go and check the code implementation. So what are the prerequisites need? Like this is the project structure. The prerequisites are we need a Python 3.11 above versions. So we need a AWS CDK and then AWS CLI. Through that, we can configure our AWS credentials details. And then we are creating the projects over here. So creating the directory and then creating the CDK Python project we are creating it. So which I already did that. Now let's go and check the implementation. So when we execute CDK in it, it will give the boilerplate of the CDK applications. So here we can see serverless app. So here we can see serverless app stack.py. Here we have to write our resources details, and then there is a entry file app.py. So it will be invoked when we are executing the CDK application, and then there is a VNV file, which is like a virtual environment file. It will store all our packages details in the specific locations, and we have a requirements.txt file. So this will have our what are the packages needed for our CDK applications. Okay. So then let's go and check the code. So as per our architecture flow, we need S3 bucket and Lambda and DynamoDB table and SNS, and then through Moto.3, which is like a Python SDK for AWS, it will connect it with AWS Rekognition platform. Okay, so these are the resources we need. Let's go and check the code. So here we can see that is media bucket, S3 bucket, we can see it. So, and then we create so here we can see results table. This is a DynamoDB table. So the file name is the partition key. And here I'm creating the SNS notifications. So I'm setting the email subscription for my mail ID. And then I'm defining my Lambda function over here. So here we can see I'm using Boto3. It's a Python SDK. I'm connecting with the regularization of the service and DynamoDB table. And then I'm fetching the records from the what it's happened when there is a event trigger, when there is a file is uploaded to S3, it will trigger the Lambda function. So it will capture the events files, take the bucket name and files details, and checking whether it's a JPG or image format data. I'm actually detecting the labels over here. So, and then checking the limits of maximum labels, how many maximum labels I can set, get that. And then I can store the details in the DynamoDB table. Okay, and then whether the file name is in with MP4, this is the video format file in OBR.av, right? So here also I'm start detecting the label detections I'm doing. So then I'm getting the details, and same like what we are doing it in the image processing, same like a video processing also we are doing it, getting the detecting the labels and storing the data in the same DynamoDB. And then finally, we are sending all the details of my analysis to SNS notebook in SNS notebook. Okay. So here I'm providing the all the permissions, providing right permission to my Lambda in table, so it can my Lambda can write the data into the DynamoDB table, and Lambda can trigger the SNS notification, and the Lambda can read the data from media bucket, and then adding the policies, so recognition can get the data from my S3 bucket. Okay, and then yeah, so these are the IAM policies we need, so that we'll have to provide. So the Lambda can do these kind of operations. So detect label, start label detection, got label detections, yeah. And then add it, this is add S3 event trigger. So when there is a file upload, it will trigger the S3 LAN. So there are two different formats. I'm passing a JPG and then MP4. If these two files has been uploaded, it will trigger the S3, like it will trigger the Lambda function. Okay. So this is the code implementation. Now let's deploy and let's do the testing. So first we have to generate the CloudFormation template for my like AWS CDK code. So using CDK sync. Next CDK deploy. So here it will list out what are the resources going to deploy. Let's do that. So it might take some time. So let's go and check the documentations. So we are creating the project and install all the required packages. So now we are this is CDK bootstrap. It will initialize the CDK project in your account. Actually, it's in specific region. CDK bootstrap and CDK deploy. So the CDK bootstrap is one time the process we have to do it. So when we are first time we are setting the CDK application in the specific region, the CDK bootstrap we have done that. And then this is about the projects like S3, the media files we are uploading it, and then if there is a lambda, it will get triggered that. For images, it will call detect labels, save the labels in DynamoDB and send SNS notification. For videos, it calls start label detection and polls get label detections until the job finishes. So, for example, the video, it will if the duration is maybe something like we don't okay, the system don't know, so it will first each and every frame or every like frame like a text frame like a video frame, so it will call the take the capture of the specific video frame and then send the details to the like a service against service, and then start label detection will detect that and then get the label detection, and then it will give the response back to uh, the same service. So it will store the service detail labels into the same service, and then it will do the same, it will repeat the same process until the video is completed, video executed. Okay. So then it will collect all the data and then it will send the cumulative data to the DynamoDB. Like it will store the data to the as a response, and then we are storing the response into the DynamoDB. Then finally it sends the response to Essence. So I hope, yeah, this is done. So now let's go and check the AWS console. So here we can see performance. Serverless abstract. The resources wise, we have a media bucket. So this is the bucket we need. That's, and then we have a auto detect object. It's three auto delete object. So and then media results table. This is like a DynamoDB table, media notifications. Since we we have SNS notifications, we have to subscribe that. So then only we can receive the emails from the AWS system. So then we have a processor lambda. Okay. So the next we have SMS notifications. So this is CDK metadata. So fine. So here we can see this is the S3 bucket. And then let's go and check the properties and permission and everything. So here I just set the filters for .jpg and input that we can extend. So we can add other filters as well. We can add it. So when these two files are added, extension files added, this will trigger this lambda. Okay. So this is the lambda we have. So then DynamoDB table. So there is no record so far. So now let's test the system. So what we are doing it. So we are going to upload some images and video files to the S3 bucket using AWS CLI. Okay. So in real world, what we can do, we can develop the front end application. From the front end application using pre-signed URL from the S3 bucket, user can upload the data from front end to the specific S3. So in there, it will start triggering the Lambda and then it will get that all the analysis from labels from like a recognition service, and then it will store the data into the Dynamo. Okay, so that is how the real world situation, like real world scenario, we can work on that. But for this demo purpose, we are actually going to upload the files from AWS CLI using AWS CLI. So now let's uh, go and check. Oh, I need a S3 bucket name. Just place it in one here. State, and then I will upload some images, multiple object impulses, so we can see. Yeah. So here we can see some like traffic areas. Okay, we can see bus, cars, a road, and this kind of city architecture we can see. So let's see, let's upload, and then what is the output we can see. Okay, let's see. So let's say it's uploaded, fine. So now let's go and check the table. Okay, so here we can see it can collect some labels. So here road, outdoors, person, car, and city. Okay, it's supposed to receive emails. Yeah. So I receive the email as well. So what is the file name, and the labels details and status of the processes. Okay, and then this is the same process for video as well. So video, let's see what kind of like so it's a kind of, yes, rotates and so it has 30 seconds. So let's try to upload. It's having 5.1.5 gigabyte. Yeah, it's uploaded successfully. Now let's go and check the label. Okay, it's taking time. Let's go and check the map. Let's check the logs. Okay, so here we receive. Yeah, so we receive the final data. Yeah, so records also we get it. So it can capture certain details here, flow, moon, moon, water, nature. Okay, so it will go and check the each and every frame, and then it will collect the data and it will send it. So this is how uh, the video analysis, the image analysis is working using the recognition service. So now I hope we discussed everything. So able as well to check that video process status, the email we received it, and then yeah, I hope that's it. We covered all the details. So you can all the source code, everything we already published. So we feel free to go and check that and do your hands-on. I think yeah, that's it from my end. So we will see you in upcoming session. We'll discuss about some other real world use cases we can discuss. Yeah. Thanks everyone. Thank you.